Today I am going to explain the system calls. In this video I am covering the low level functions which are used to access the device drivers. These functions include four main system calls. First is the open system call, which is used to open a file or a device. Second is the read system call, which is used to read from an open file or a device. Third is the write system call, which is used to write to a file or a device. And fourth, that is the last, is the close system call, which is used to close a file or a device. Now you may be thinking that what is a system call? Basically, system calls are functions only which are provided by Linux to create an interface with the operating system. So consider an example that I am a user and I am writing my program by using some of the libraries. So this entire space becomes a user space. Whereas on the other side, I have my hardware devices. Consider an example of tape drive. Now, if I want to access this device, then I need to use a system call. So, from my user space, I make a call to the heart of the operating system, which is a kernel where the device drivers are present. So, this space becomes a kernel space. So if I want to access my tape drive, that is the operation like forward or backward, then I can make a call, and these calls or these functions are called as system calls. Now I have written a program in my text editor where I have included all the system calls. So we will see one by one what all the system calls mean. First, I'll tell you what I have written in my program. I have included the four system calls, that is open, write, read and close. First, your open system call. Now we will check what this open system call mean. I'll open a man page of this open system call and check what this means. If you observe this open system call, it has two parameters in it. First is the path name and second is the flags. Now, if my file is present in the same directory, then I can just name that file as I have written in my program. I have just named the file, that is check.txt. I have already created a file, so I have named it by the name check.txt. If you have not created a file, you can use this system call, that is create system call, and your file can be created also. Now if your file is not present in the same directory, then you have to mention the entire path which is starting from the root directory. This second is nothing but the flag. These flags include three main modes. Here they have mentioned the modes. First is the read only mode, second is the write only mode, and third is the read write mode. In my program I have used the read write mode because I am operating on the file with read operation also and write operation also. Now this open system call returns a file descriptor. I have taken an integer variable, that is fd, which is used to store the file descriptor. Now I have printed the file descriptors here. The basic file descriptors, that is 0, 1 and 2, are already assigned to standard input, standard output and standard error. So generally for such operations, file descriptor, that is number 3, will be assigned to our operation. Now this open system call, if it is successful, then all these operations will be performed. Whereas if this open system call fails, then it returns a value which is -1. So I have written a condition where I have first printed my check.txt open with read write access. It is just a printf message. Next is the write system call. So now we will check the man page of this write system call. If you check this, the write system call has three parameters. First is the file descriptor. So in my file also I have included the file descriptor which has been written by this open system call. So I have included the first parameter as fd. Second parameter is nothing but your buffer, means where you want to write or what message you want to write. So I have created a string here where I am printing hello iFocus Institute, and I have included this variable, that is message, in as my second parameter in my write system call. And the third parameter is nothing but the count. Count indicates how many bytes you want to write to that buffer. Here I have taken a function that is size of message, so it will check the maximum bytes of this variable and it will assign it here. Then I have used a system call which is lseek. Now why we have used this system call, that is lseek, because I want my file to be read from the first data byte itself. So I have to assign an offset here. If you check the man page, the first is the file descriptor only, so I have included in my file the file descriptor. Second is the offset, and by default value for this offset is 0, whereas the third parameter is whence. Whence can take three values. Seek set, which is nothing but offset, directly is assigned to this value. Next is seek current, in which the offset is current location plus your offset bytes, and the secant is nothing but the size of the file plus your offset bytes. So in my program I have included the first parameter, that is seek set. Now next is the read system call. Now we will check the man page of this read system call also. If you observe this, again there are three parameters here. First is again the file descriptor. So if you observe, every system call has the first parameter as the file descriptor only, which was written by your open system call. Second is the buffer. So in my program I have created a string again by the name buffer, and I have included here as a second parameter. Why? Because whatever the bytes that will be read by using this read system call will be stored in this buffer, and the last parameter is nothing but the count, that is the number of bytes that will be read. So I have again taken a function that is size of, which will count the maximum number of bytes in that message. Then I have just printed %s, that is for string, was written to my file. So this message should be printed at this printf statement. And after all these operations, that is after opening a file, then writing a message to it and reading that message, I have closed my file by using a close system call. Again I'll open a man page for this close system call and check. It includes only a single parameter, that is the file descriptor, which I want to close. So I have included the file descriptor, that is fd, which was opened using the open system call. Now I have saved this file by using example.c. In my terminal, I'll run this program by using the gcc command. I want the output by the name example, and my file name is example.c. It has been compiled successfully. Now I'll run it. So if you observe, the file descriptor that has been written is 3. So 0, 1, 2 have been already assigned. So the next descriptor, that is the number 3, has been assigned to our operation. Then I have just printed that check.txt opened with read write access. So our file has been opened successfully, and the message, that is hello iFocus Institute, that was written to my file